Hello everyone and very good morning. I hope you all are good. So today in the class we are going to revise simple harmonic motion, and before moving on with questions, let's first have a recap of what different things can come in SHM. So SHM का simple मतलब आप लोग समझते हो. SHM meaning simple harmonic motion. This is a sort of periodic motion. You already know this. ठीक है? And what is the condition of SHM? For SHM to be there, acceleration should be directly proportional to negative of displacement. What does it mean? It has a simple meaning. Acceleration ka magnitude will be directly proportional to displacement ka magnitude, and direction of acceleration at any point will be opposite to the direction of displacement at that point. So this is the very much basic equation of SHM. And if you talk about angular SHM, that is if some body is, let's say pendulum is moving to and fro, and such that this displacement angle is very, very small, then it will also perform SHM. We have learned it. And here alpha becomes alpha, that is your angular acceleration, become directly proportional to minus of delta theta, that is smallest displacement, or you say theta, where theta will be small displacement. So these are the characteristics. And the most common SHM that we encounter in our question is spring mass system. So in a spring mass system, you already know force is equal to minus kx. Force can be written as ma, and this is minus kx. So A can be written as minus k by mx. You can see here A is directly proportional to x, and direction of A is opposite to the direction of displacement. What is this k by m if you talk about? So when you talk about acceleration thing, or SHM thing, A is directly proportional to x, then this proportionality constant is equal to omega square x. So in the case of spring mass system, this omega square is equal to how much? You can see from here, k by m. So this is k by m. Omega is equal to root under k by m. This is very, very important. यहाँ से maximum questions होंगे. So this is important. Next, we will calculate time period. That is your 2 pi by omega. So you can clearly write this thing. Now coming back to writing the equation in terms of sine and cos. So if you see here, if we have SHM of the sort where body initially is at equilibrium position, we define two positions. One is equilibrium position, another is your extreme position. So at equilibrium position, we say displacement of the body is zero. And in that case, we say that this spring is not stretched. So this is basically unstretched at equilibrium position of the body. Okay? And if body initially at t equal to 0, it is at x equal to 0, then displacement of body as a function of time t, when it will start moving, can be written as a sine omega t. What does it mean? A is the amplitude of the body, omega is the angular frequency, जिसका value अभी अभी हमने देखा. And why I have taken here sine function? Sine function I have taken because initially, that is at t equal to 0, body is at equilibrium position, that is x equal to 0. जैसे यहाँ पे if you go on to put t equal to 0, you will be getting t 0 कर दो, sine 0 will become 0. So x का value if you go on to calculate at t equal to 0, you will get 0. Why you will get 0? Because sine 0 is 0, right? So when body starts its simple harmonic motion from the equilibrium position, we write it like a sine omega t. Okay? But what if body is, let's say someone says you that body is at equilibrium, at extreme position at the time t equal to 0. Write the equation of SHM. So when it is at its extreme position, its equation is written like this: a cos omega t. Or you can write it like this. Initial equation को ही translate कर दो. Sine, चलो let's write the sign itself. So here what I'm going to do is a sine omega t plus pi by 2 I'm going to write. ठीक है? So if you look at it, now if you calculate x का value at t equal to 0, you will put here t equal to 0, you will get a sine pi by 2, which will give you a. So initially body is at extreme position. So this displacement is equal to a. And that is why this will be the fitting equation. Sine omega t plus pi by 2 can be written as cos omega t. ठीक है. So this is how we write equations. After that, if you talk about energy of SHM, जैसे अभी अभी हमने क्या क्या पढ़ा, we talked about acceleration. Acceleration is minus omega square of x. We talked about x. X can be written in terms of sine or cos. We have already talked about it. Now if you want to calculate the velocity, so velocity के लिए you can differentiate with x with respect to time, है ना. जैसे x अगर तुम्हारा a sin omega t है, if you go on to differentiate with respect to time, then you will get velocity equal to a omega cos omega t. So time or as a cos or sine function, you can write velocity in this way. If you know x, you can calculate v. But v का एक और formula है, that is maximum velocity will be equal to how much? Omega a. So that is also equal to omega a root under 1 minus x square by a square. So in the question, if you get asked like, sorry, I forgot to turn on my camera. So in the question, if you get asked about calculate the velocity of body at any time t, then you can use this formula, time wala. And if you are asked calculate the velocity of body at a particular displacement, if the value of x is given, you are asked to calculate v, put in this formula. Okay, so this way you can solve it. And if you talk about finally the energy of SHM, spring mass system के case में अगर आप देखो, तो energy at any particular displacement, let's say body is here at any time t, and this displacement is x, then it will have two sort of energy, potential plus kinetic. Potential energy will be equal to how much? Half kx square. What will be the value of kinetic energy? Half mv square. Okay. So at any time you can write energy as equal to kinetic plus potential. And if you go on to, I mean, if you want to write the velocity का value in terms of just now the formula that I gave you, जैसे अगर आप इसको ऐसा करोगे, you all must have studied this thing. V square को क्या लिखोगे? Omega square a square. रूट अंडर क्या था? 1 minus x square by a square. इसका स्क्वायर कर दो. ठीक है. So there is little space here. Let's not write it here. Let's do it in the next page. So I mean, what is the energy? Half kx square plus how much? Half mv square को क्या लिखोगे? Omega square a square 1 minus x square by a square. So if you put this thing, if you solve it, why I'm doing this much? Just to make you more comfortable with the formula things. ठीक है? So यहाँ से अब आप solve कर लो. You will write omega square a square minus what you will be writing? This will become ओमेगा स्क्वायर एक्स स्क्वायर. नाउ व्हाट इज द वैल्यू ऑफ ओमेगा? ओमेगा का वैल्यू अभी अभी हमने पढ़ा था, इट वाज इक्वल टू के बाई एम. तो इफ यू ब्रेक अगेन, ये फिर से यूज आया. ठीक है, दिस इज वेरी इंपॉर्टेंट फॉर्मूला. हाफ के एक्स स्क्वायर प्लस हाफ एम. ओमेगा स्क्वायर को आप क्या लिख सकते हो? के बाई एम ए स्क्वायर माइनस ओमेगा स्क्वायर को क्या लिख सकते हो? के बाई एम x square. So if you put in this thing, what you're getting, you will get an interesting result. And this will become half ka square. This will become minus half kx square. So at any time t, we calculated the energy that is equal to half kx square. That is equal to maximum potential energy. So at any time t, total energy sum will be always equal to half ka square. Okay? And this half ka square at the extreme position will only exist as potential energy, and at any other position it will exist as the sum of both potential and kinetic. Also at the mean I mean at the equilibrium position there will be only kinetic energy. अगर आप इसकी बात करो, so if your body is at x equal to 0 वाला position, that is equilibrium position, then here mechanical energy is equal to kinetic energy. There is no potential energy because extension in the spring is 0 or compression. So this can be written as half ka square. At any extreme position, if you talk about at displacement x equal to a, here there won't be kinetic energy, 0. Potential energy will be equal to total energy, that is half ka का square. So this is how you can represent different things. उसके बाद है तुम्हारा velocity, acceleration और displacement का graph. So if I say displacement is equal to a sin omega t, then इसका ग्राफ आप कैसे बना सकते हो? साइन का ग्राफ. ठीक है, so this is how, this is what sine graph look like. साइन का ग्राफ कैसा होता है, ऐसा होता है. एंड इफ यू कैलकुलेट वेलोसिटी हियर, यू विल गेट a omega cos omega t. So you have to again draw the graph of cos omega t. That will look like this. And if you have to calculate acceleration, that will again you differentiate it. You will get minus a omega square sin omega t. A sin omega t को, I mean minus sin omega t का ग्राफ कैसा होता है? So this will simply mirror image of the first graph. क्योंकि here this is the graph of sin omega t, this is going to be the graph of minus sin omega t. So this will look like this. Done it? So this is xt curve and this is vt curve, this is at curve. So this is how we can draw different curves. We can check the phase differences, right? So in between these two, phase difference is 90 degree, and in between these two, phase difference is 180 degree, and in between these two, similarly, you can I mean you can see here, this is plus 90 and this is 180, so some sort of 270 something it will go, but you can do it more mindfully by checking with the equation. Okay, so this is how you can solve questions. Now potential energy का भी curve होता है, and that curve will look like, let's say this is x equal to 0. So at x equal to 0, I told you there will be minimum potential energy. So potential energy graph will look like this, and kinetic energy graph will look like this, such that their total energy will be always equal to this. That is half Ka square. So this is the curve of your kinetic energy. This is the curve of your potential energy. ठीक है? पोटेंशियल और काइनेटिक को सेपरेटली हम लिख सकते हैं. काइनेटिक को एट एनी टाइम यू कैन राइट लाइक हाफ mv स्क्वायर. So basically this curve is the curve of cos square omega t, and this is the curve of what sin square omega t, sort of you can say. ठीक है? So this will look like this. ठीक है? Now we will solve the question. So let's start with questions. Now you can take your time, you can do it. Anyone who got the answer? Okay, I got one correct answer, one is wrong. Okay, let me. Yeah. I'm really sorry I lost the connection basically. So let me say the thing. Okay. Now let's start. I mean, so here displacement is given, right? Displacement is given as a cos omega t I cap plus 2a cos omega t j cap. So it is something like some displacement is in x direction and some displacement is in y direction. If you look at here, x ka value kya hai? A cos omega t, and y value is given as how much? 2a cos omega t. If you compare x and y, you can simply see here y is equal to 2x, right? So this is basically equation of y as a function of x. So y and x are related like this. Now let's read the question. So what is this? What will be the path? Will it be I don't know why it is happening. Connection is getting interrupted time and again. I'm really sorry for this. Okay. Okay. Am I audible perfectly? Am I audible to everyone? Yes. Okay, okay. Thank you, thank you. So, first statement is wrong. I mean, parabolic path, it cannot be. Elliptical, it cannot be. It can only be a straight line. It will be periodic motion because it is sum of two SHM. So, it is periodic. Is it simple harmonic? Yes. Because it is sum of two simple harmonics. So, it will be simple harmonic. Correct answer will be what? C and D. So, option is D. Now, let's do this question. Okay, I got one answer, but that doesn't feel correct. You need to recheck with the formula. Formula सही से check करो तुम लोग. क्वेश्चन क्या है, पार्टिकल एग्जीक्यूटिंग सिंपल हार्मोनिक मोशन विथ एम्पलीट्यूड ए हैज द सेम पोटेंशियल एंड काइनेटिक एनर्जी। अगर आप पोटेंशियल एनर्जी की बात करो तो क्या लिखोगे, हाफ के एक्स स्क्वायर। इफ यू टॉक अबाउट काइनेटिक एनर्जी देन यू विल राइट हाफ एम बी स्क्वायर। ठीक है, एंड दीज टू थिंग्स आर सेम, potential and kinetic at certain displacement is same. So the question is, what will be that position of particle where these two things will be same? So आप इन दोनों को इक्वेट कर दो, हाफ के एक्स स्क्वायर इक्वल टू हाफ एम वी स्क्वायर को हम क्या लिख सकते हैं, क्योंकि यहाँ पे देखो एक्स के टर्म में है ये पोटेंशियल एनर्जी, kinetic energy also we need to write in the terms of x. So if you write in the terms of x, that this will become omega square a square 1 minus x square by a square. क्यों? क्योंकि velocity का formula we know that is omega a 1 minus x square by a square. So this thing I have written here. half को आप कैंसिल कर दो, k x square will be equal to how much, omega square को आप ब्रेक कर दो, omega square will be equal to how much, it will be equal to k by m into a का square 1 minus x square by a square. You simply need to put in the formula. अब आप यहाँ पे solve कर लो, kx square equal to m will get cancelled. So this is ka square minus kx square. So if you solve it, you will get 2kx square is equal to ka square. Now you can clearly see the answer, right? Sorry, not this. I mean, not this one will get cancelled. You can cancel now what? K and K will get cancelled. X equal to a square by 2 ka root under. So you will get a by root 2. So correct answer will be what? It will be C. So this question is all about formula. If you remember it, you can simply do it. Chalo, do this and let me know. Let's practice some question, okay? Even if it is not happening as of now, after doing 10 or 12 questions, we will be, I mean, so much done with the formula thing and concept also. So let's do it. पेंडुलम का टाइम पीरियड कैसे बनाते हो, अगर इफ देयर इज पेंडुलम हैंग विथ अ स्ट्रिंग ऑफ length L, then let's say its mass is m, then time period is written as 2 pi root under L by G, where G is G effective. Yani ki G, I mean, this G effective can change, but when it is on the earth, just kept in, not inside the rotating car or moving car, not on a lift accelerating or something, then it is simply 2 pi root under L by G. Anyone who got the answer? Nobody? You just need to put in the formula. Please put it. What is the time period initially? Time period initially will be 2 pi root under L by G. What is happening finally? It's, I mean, if the mass of Bob in a simple pendulum is increased to thrice its original mass, but time period is not depending on mass. It is independent of mass, right? So with mass changing, time period will not change. But one more thing we are doing, its length is made half its original length. Okay? So length, let's say initial length was L0. So initial time period is this one. Now we are making length half. Then the new time period of oscillation is x by 2 times its original time period. So final time period is x by 2 times t naught, and this will be equal to 2 pi root under L naught by 2g. ठीक है. Then the value of x is what? This thing we have to calculate. So if you put the value of t naught here, you will get x by 2 root under L naught by g into what you are going to put here, into 2 pi, and this is equal to 2 pi root under L naught by 2z. ठीक है. This 2 pi will get cancelled, this L naught will get cancelled, g will get cancelled, and x is equal to 2 by root 2. So this will give you root 2. So correct answer will be what? It will be B. ठीक है. I mean, this is also coming directly from the formula. You just need to remember time period formula of pendulum hanging from a string. This is 2 pi root under L by G. So if question as simple as this is coming, you should be doing it. There should not be any excuse in this. है ना? Okay, again, the same use of formula and all. Try this question. If you're not able to do, I will definitely help. So try doing. Okay, I feel like I should be or we should be doing it together. ठीक है. So अभी अभी मैंने एक चीज बताया, टाइम पीरियड हम निकालते कैसे हैं. बाई I mean if there is a string hanging, if there is a pendulum hanging with the string like this, time period we simply write like 2 pi root under L by G. But this G is basically G effective. अगर तुम्हारा पेंडुलम, जैसे इस चीज को ध्यान से देखना, if your pendulum is simply here standing like this and it is in rest, ठीक है. Whenever you write the formula T equal to 2 pi root under L by G, G effective, and how you calculate G effective? By assuming or by taking a position of equilibrium of this pendulum. Okay? So let's say this is hanging from a string like this, it is in rest, then tension is acting upward and downward mg. So T is equal to how much? M into G. So in every case, you have to simply equate T to something, and that something will be mass into whatever, and that whatever is the G effective. So here G effective is G itself. So we will write like this. But let's say now you are putting this same pendulum inside a car. Okay? Now it is inside what? It is inside a car, and this car is moving forward with acceleration A. Now what will happen? अब क्या होगा देखो. अब तुम्हें इसके इक्विलिब्रियम पोजीशन को लिखना है. सो इफ यू नाउ राइट द इक्विलिब्रियम ऑफ दिस थिंग, दिस पेंडुलम, टेंशन एक्टिंग अवे, एंड because this is inside an accelerated frame, and if I write equation from here only, I will apply here pseudo force, and that is equal to ma, and then this is mg. Done है. अब देखो, if this pendulum has to be in rest, it won't stay like this, क्योंकि tension is acting, I mean tension direction can change according to string changing. स्ट्रिंग क्यों चेंज करेगा यहाँ पे? जैसे आप देखो, इस पे mg फोर्स डाउनवर्ड लगा, ma फोर्स इज एक्टिंग टुवर्ड्स द लेफ्ट. net value of force because of mg and ma will be in which sense? It will be in this sense, right? So this pendulum in this case will go like this. Why it will go like this? Because it is experiencing net force in this direction, and hence tension will balance that net force. So here tension will be equal to how much? Resultant of these two forces, that you will write m square a square plus m square g square. Okay? So that will be equal to m root under a square plus g square. So here tension is equal to mass into something, that something is this, and this will be your g effective. Okay? Similarly, if there is a car and that is slipping down an inclined plane, simply if it is slipping down, it will have acceleration of g sine theta. If this is theta, then pendulum here will again, you will apply the same thing, you will calculate net force, and in this case g effective you will be getting at g cos theta. Okay? So I feel like now you know how to do it. So in our question case, what is there? There is a simple pendulum oscillating in air, has a time period t. So when it is oscillating in air, it has a time period t. So in air, only force acting is T and mg, T equal to mg. Here G effective is G. So here time period is simply equal to 2 pi root under L by G. Okay? Now what we are doing with it, the bob of pendulum is completely immersed in a non-viscous fluid. Now it is completely immersed in some fluid. The density of fluid is 1/6 of the material of the bob. Density value is given. We have to calculate its time period value in this case, right? If initial time period is t in air. So let's go through the case. What we will do here? So let's take a beaker container. This is filled with water, and now your pendulum is inside it. Which forces will act? Simply you have to write Fbd in equilibrium. So here tension downward mg, and mg is equal to volume of body into density of body into g, right? Mass into g. Mass can be written as volume into density. And in the upward direction, force of buoyancy will act, which is equal to volume of displaced liquid into density of liquid into g. Since whole body is inside the fluid, volume of displaced liquid will be equal to the volume of body. So V rho L into G. If you write the equilibrium condition, you will write here T equal to, how much you will write? आप क्या लिखोगे बताओ? T के डायरेक्शन में कौन कौन से फोर्सेस है? T प्लस V rho L G is equal to V rho G. So T equal to how much? It is V G कॉमन ले लो आप, रो L माइनस रो. ठीक है? नो, रो माइनस रो एल, सॉरी, रो माइनस रो एल. नाउ लेट्स टेक रो कॉमन. रो मैं कॉमन इसलिए ले रही हूँ क्योंकि आई हैव टोल्ड यू जी इफेक्टिव कैसे निकालते हैं. एम इनटू समथिंग, व्हाटएवर इज समथिंग दैट इज जी इफेक्टिव. सो लेट्स राइट एम आउटसाइड. सो रो को मैं कॉमन ले रही हूँ. वी रो जी. If rho I'm taking outside, this will become 1 and this will become rho L by rho like this. So V rho is equal to mass. Mass into क्या आ रहा है? 1 minus rho L by rho into G. So this whole is your G effective. ठीक है? So if you now go on to calculate time period will be equal to 2 pi root under L by G effective. What is the G effective? 1 minus rho L by rho into G. ठीक है? अब आप इसको वैल्यू को पुट करो. 2 पाई, दिस इज रो एल इज 1/16 टाइम्स, राइट? सो इफ वी सॉल्व दिस थिंग, रूट अंडर 1 minus रो एल by रो एल इज 1/16 of रो, so you will write 1 minus रो by 16 into रो is here. This will get cancelled and this will become 15/16 root under. So this is 15/16, so this will become 16L by 15G. अगर आप इसको अब लिखो, यू विल राइट इट लाइक दिस. 2 पाई रूट अंडर L by G into root under 16/15. So 2 pi root under L by G is equal to how much? That is equal to T, already given. And this is equal to root under 16 will become 4. 4T into 1/15 root under. ठीक है? So what should be the correct answer? 4T root under 1/15. That should be third one. ठीक है? So this is how we calculate G effective and this is how we calculate what time period for pendulum cases. ठीक है? तुम लोग को ज्यादा से ज्यादा कहां तक आ सकता है? इस फ्रेम से आ सकता है एक कार के अंदर है विच इज एक्सेलरेटिंग हॉरिजेंटली, जी इफेक्टिव इज रूट अंडर ए स्क्वायर प्लस जी स्क्वायर. इंक्लाइन प्लेन पे अगर वो जा रहा है कार, then it is coming down with acceleration g sin theta. If it is freely coming down, then g effective will be g cos theta. These two cases, and third one is with the application of force of buoyancy. So you should remember. और इवन इफ इन लिफ्ट इट इज हैपनिंग, जैसे अगर तुम्हारा लिफ्ट ऐसा है, देर इज अ पेंडुलम एंड इट इज गोइंग अप बाय दिस, डन है. सो इन दैट केस जी इफेक्टिव विल बी हाउ मच, जी माइनस ए. डन है. In this case it will be g plus a, sorry, it will be g plus a. And if lift is also going down, what is uh, pend- I mean lift is going down with acceleration a, then g effective will be g minus a. ठीक है. क्योंकि अगर आप सॉल्व करो ना, जैसे लेट मी टेक अ ब्लैंक पेज, अगर आप लिफ्ट का केस सॉल्व करते हो, दिस इज द लिफ्ट, it is going up with acceleration a. Sitting over here, write the equation. So you will apply pseudo force here. ठीक है. pseudo force कितना जाएगा, ma in the downward direction because acceleration is upward, tension t equal to क्या लिखोगे, mg plus a. So g effective here is g plus a. In another case it will become g minus a. So like that you can solve. Now let's do this question. Take your time, do it. Okay, I got one correct answer. That is great. Okay. Chalo, let me end the poll here. So, total mechanical energy is conserved. First thing, if energy is conserved, I mean, it won't, it will convert from one form to another, but total will remain constant, right? So, which one will match with it? Even if you are confused, move ahead. See other options. जहाँ पे आपको clearly दिख रहा हो. Bob of a pendulum is oscillating under negligible air friction. So when there is no air friction, then bob of pendulum is oscillating. Restoring force of spring. स्प्रिंग के रीस्टोरिंग फोर्स का फॉर्मूला क्या होता है, माइनस के एक्स. और एफ, अगर ये एफ है और ये एक्स है, एफ इक्वल टू माइनस के एक्स का डायग्राम ऐसा होगा. सो सिम्स लाइक बी इज द करेक्ट ऑप्शन फॉर दिस. डन है. वेयर वाई इज एफ एंड एक्स इज एक्स. राइट है. bob of pendulum is oscillating along with air friction. आप लोगों ने पढ़ा होगा डैम्प्ड ऑक्सीलेशन. डैम्प्ड ऑक्सीलेशन का अगर डायग्राम सबको याद हो तो ऐसे दिखता है. ये क्या था, ये था हाउ द एम्पलीट्यूड ऑफ ऑक्सीलेशन विल डाई डाउन विथ टाइम. ठीक है. तो इफ हियर y इज एम्पलीट्यूड एंड दिस x एक्सिस के अलोंग अगर टाइम है, देन विथ टाइम एम्पलीट्यूड विल डाई डाउन. इट विल ऑलमोस्ट बिकम जीरो आफ्टर सर्टेन टाइम. सो डैम्प के लिए डेफिनेटली तुम्हारा क्या करेक्ट होगा, फोर्थ के लिए ए. नाउ कमिंग बैक टू अनदर टू, बॉब ऑफ पेंडुलम इज ऑक्सीलेटिंग अंडर नेग्लिजिबल एयर फ्रिक्शन. अगर एयर फ्रिक्शन is there, then amplitude is like this. It is dying down. If there is no air friction, amplitude will remain same. So it will keep on oscillating. So normal oscillation का diagram होगा. So for this thing, सेकंड के लिए क्या होना चाहिए, दिस वन. एंड फाइनली टोटल मैकेनिकल एनर्जी इज कंजर्व्ड, सो दिस विल बी दिस वन. क्योंकि अभी अभी मैंने तुम लोगों को बताया था एनर्जी का डायग्राम ऐसा. अगर आप इस साइड के डायग्राम को हटा दो तो इट इज लुकिंग लाइक दिस. दिस इज द डायग्राम. सो फर्स्ट के लिए फोर्थ वन. ठीक है. सो दिस वे यू कैन मैच इट. अगर फर्स्ट स्ट्राइक नहीं करता है तो मूव अहेड, क्योंकि दो सॉल्व हो गया तो एक अदर टू में यू कैन जस्ट अप्लाई सम memory, some concept, some, I mean, anything like that. Chalo, let's now do this question. Just look at the diagram and then try attempting. Okay, I got one answer, but sign में तुमने गलती करी. Check the sign. Negative, positive दोनों आंसर्स है ना. Check the sign. Okay, let's discuss it now. So, what is the question? XT graph is given. ठीक है. The acceleration of particle at t equal to 2 seconds. How we calculate acceleration in SHM? That is equal to minus omega square x. This is this, right? So what will be the thing? Shashank, you are wrong with the direction. You need to check with the direction. So acceleration क्या होता है? Minus omega square x. T equal to 2 second की बात हो रही है. So if you talk about t equal to 2 second, displacement is this, right? This is the displacement. Displacement is positive, right? X equal to 1. That is positive displacement. So acceleration has to be negative. Done है. So A is equal to आप क्या लिखोगे? Minus of omega square. X का value at t equal to 2 second is how much? 1. So यहाँ मैंने 1 रखा. Now we need to calculate omega. T equal to क्या होता है? 2 pi by omega. If you look at the diagram, then one time period is equal to how much? 8 seconds. In 8 seconds it is completing the cycle, so time period is 8 seconds, that is 2 pi by omega. This will become this. Omega is your pi by 4. ठीक है. So omega square आप क्या लिखोगे? Pi square by 16 into 1. So correct answer will be not plus pi square 16 minus pi square 16. Why not plus? क्योंकि x तुम्हारा पॉजिटिव है, यानी कि अगर किसी भी पोजीशन पे बॉडी का डिस्प्लेसमेंट इज इन दिस डायरेक्शन, then acceleration has to be in this direction. One is positive, another will be negative. Simple. So correct answer will be your C, not B. Done it? Now do this question. Anyone who got it? Yes. Okay, you need to just check with a body is executing simple harmonic motion with frequency A, the frequency of its potential energy. Let's say displacement is A sine omega t. Then frequency of this simple harmonic motion is how much? Omega is the angular frequency and omega is equal to 2 pi f. So that frequency in hertz can be written as omega by 2 pi. That is 1 by time period, right? Time period is 2 pi by omega. Frequency is omega by 2 pi. So this is this. Now the frequency of its potential energy. Potential energy, koi bhi x displacement pe, we write it like what? Half kx square. So this is half k, x ka square karoge, you will be getting sin square omega t. So sin square omega t का जो frequency होगा, that will be the frequency of potential energy. Simple harmonic motion का frequency क्या होगा? जो sin omega t का frequency. So frequency means 1 by time period. अब देखो sin omega t का मैं ग्राफ बनाती. So sin omega t का ग्राफ ऐसा है. It is getting repeated after this time. After this time, like this, done है. So sin omega t का ग्राफ आपने ऐसा बनाया. What is the graph of sin square omega t? Since this is a square, there won't be negative portion like this. So it will look like this. ठीक है. So इसका टाइम पीरियड क्या हो गया? इसका टाइम पीरियड हाफ हो गया. डन है. इसका टाइम पीरियड यहां तक है t and its time period is this. So t and t dash are related like one is half of another. So if time period is half, frequency will be double. अगर तुम्हें ग्राफ से नहीं सॉल्व करना, यू कैन ऑल्सो सॉल्व फ्रॉम द इक्वेशन. जैसे मैंने एसएचएम का फ्रीक्वेंसी इक्वेशन से निकाला ओमेगा बाई 2 पाई. ठीक है. व्हाट विल बी द वैल्यू ऑफ ओमेगा हियर? तुम लोग ये सोच रहे होगे कि यहाँ भी तो ओमेगा ओमेगा है, बट दिस इज साइन स्क्वायर. You need to have a linear function of sine, that is only single power of sine or cos. So half ka square sin square omega t को हम क्या लिखते हैं? 1 minus cos 2 omega t by 2. So this will become how much? 1 by 4 ka square 1 minus cos 2 omega t. So frequency, I mean, why this potential energy will oscillate? Not because of this constant term A, but because of this variable term cos 2 omega t. And what is the frequency of this cos 2 omega t? इसका frequency क्या लिखोगे? Omega by 2 pi. Its omega value is 2 omega. So this is 2 omega by 2 pi. So this is omega by pi. Done it? And here it is omega by 2 pi. So if this is f naught, then omega by pi को आप क्या लिख सकते हो यहाँ से? 2f naught. So its frequency will be double. You can solve either way. ठीक है? Is it clear, everybody? Okay, let's move ahead. Let's do this question. Hello, if you are not able to do it, I will do because, okay, I got one correct answer. That's great. Okay, let's discuss it. What is given? The radius of circle, the period of revolution, initial position, and senses of revolution. Everything are indicated in the figure. Y projection of radius of vector of rotating particle. So y as a function of time t लिखना है मुझे, ठीक है? So at t equal to 0, particle is where? T equal to 0, particle is here. And this is origin, right? So at t equal to 0, y value is the maximum, ठीक है? So along y axis, if you write equation along y axis, it is at its extreme position, है ना? Here at a distance a. So equation अगर आपको लिखना है, you will use cos. You will write y is equal to a cos omega t. Why I'm writing cos omega t here? Just give me 1 second. There is some insect. What is that called? Bees or something. Okay. Anyway, y equal to a cos omega t, and then because if you put here t equal to 0, you will get y equal to a. Then and which is true here. Now we need to put the value of omega. T equal to how much here? 2 pi by omega. So time period is given 4 seconds. 2 pi by omega 2. Omega will become how much? It will become pi by 2. So omega here is your pi by 2 t, and a ka value is given as how much? 3 meter. So y will be 3 cos omega value how much? Pi by 2 t. ठीक है? So this answer should be C. Done it? So this way you needed to write. Done it? इसलिए एसएचएम जब तुम कर रहे हो ना, क्वेश्चन साइन कॉस इक्वेशन क्लियर होना चाहिए, ग्राफ क्लियर होना चाहिए, ऑल्सो इट शुड बी क्लियर कि हाउ वी कन्वर्ट साइन टू कॉस, कॉस टू साइन विथ प्रॉपर साइन. सो प्लीज एक बार ज्योमेट्री ट्रिग्नोमेट्री को सही से चेक कर लेना. Slight trigonometry, it's not something very much deep or something, it's just a glimpse of it, and that also a very much fleeting glimpse I've said. Not too much you have to look at it, just a little bit. ठीक है, तो एक बार जरूर चेक करना. Now do this and let me. Very good, I got one correct answer. Okay, one more answer. Okay, let's discuss it now. So what is the question? We are given SHM like this. I mean, equation कैसा लिखा हुआ है? Y equal to A naught plus A sin omega t plus B cos omega t. So SHM will look like what? Y minus A naught is equal to A sin omega t plus B cos omega t. दिस इज योर एसएचएम, राइट? मैंने ए नॉट को इधर इसलिए लिया है, देखो अगर तुम y इक्वल टू देखते हो, दिस ए नॉट इज अ कांस्टेंट, इट इज नॉट वेरिंग विथ टाइम. सो व्हाट इज नॉट वेरिंग विथ टाइम विल नॉट कंट्रीब्यूट इन द कैलकुलेशन ऑफ एम्पलीट्यूड. ठीक है, इट्स ऑल अबाउट कि वेयर यू आर फिक्सिंग द ओरिजिन एंड ऑल. ठीक है, इसका एसएचएम से कोई लेना देना नहीं. आई मीन एक्चुअल में नहीं है, एम्पलीट्यूड में कोई इसका कंट्रीब्यूशन नहीं होगा. So amplitude में which two terms will contribute, which is varying with time as a sine or cos function. So A sin omega t, B cos omega t. Then how you will calculate the amplitude? Simple, मैं वेक्टर मेथड से जाती हूँ. So जब भी तुम्हें एम्पलीट्यूड निकालना हो, फंक्शन डिफरेंट डिफरेंट दिया हो, B cos omega t है. So एक काम करो, sin omega t का लाइन ले लो ऐसा. Sin omega t का लाइन is this vectorially. Then here the amplitude is what? A. And this is cos omega t. Convert cos into sine. So you can write it like B sine omega t plus pi by 2. So if this is omega t का line, ठीक है, जैसे बेसिकली यहाँ पे क्या है ना, साइन लिखना भी ज्यादा सही नहीं होगा एंगल के टर्म में हम सिंपली बढ़ेंगे. सो लेट्स से दिस इज एंगल ओमेगा टी. बट वेन एवर यू यूज द वेक्टर मेथड, मेक श्योर कि जितने भी एसएचएम को आप ऐड कर रहे हो, all SHMs are in same function. Either all are in sine function, either all are in cos function. So here one is in sine function, another in cos. So I have converted cos to sine like this. ठीक है. Now I have taken one vector directed along the direction of omega t. So along the direction of omega t, which one is there? A sine omega t. So amplitude is A in this sense. And then there is another vector in the direction of omega t plus pi by 2. यहाँ से कितना डिग्री ऊपर जाना है, प्लस करना है, तो एंटी क्लॉकवाइज मूव करोगे, कितना एंगल? पाई बाई 2. सो बी विल बी समवेयर हियर. डन है. नाउ व्हाट इज द सम ऑफ दिस टू वेक्टर्स? तो इन दो वेक्टर्स का सम क्या लिखोगे? ए स्क्वायर प्लस बी स्क्वायर, 2ab cos 90. So that will give you how much? Root under a square plus b square. This is how we solve or we calculate amplitude. If terms are given like this, constant, you don't have to get bothered by it. ठीक है. चलो, let's I will make you understand this question because we don't have time. So whenever we cut a spring, ठीक है, जब भी तुम्हें spring दिया हो and you are cutting the spring, so spring constant is inversely proportional to length. Suppose कर लो, you had initially a spring of length L0 and it had a spring constant K. Now what you are doing, you are cutting it into two equal lengths, L0 by 2, L0 by 2. What will be the spring constant of these two springs? It will become 2K. 2K. Why 2K? Because K is inversely proportional to length. If length is decreasing by half, K will increase by two times. ठीक है? It is like this. And how we add springs in series and parallel? When springs are connected in series like this, K1, K2, K3, then we add springs like 1 by K1 plus 1 by K2 plus 1 by K3. This is how we write K equivalent in series. This one is for series. And in parallel, what we do? K1 plus K2 plus K3. This is the formula in parallel. ठीक है? So opposite to what you have studied for register. ठीक है. चलो. So my best wishes with each one of you. I just wish you people prepare well. I mean, you have already prepared, so just keep on doing questions, more number of questions in the coming days. ठीक है. डन है एवरीबडी. सो आप लोग सही से क्वेश्चन करना और एग्जाम को दिल लगा के देना विदाउट टेंशन लिए हुए. जो भी 3-4 दिन बचे हुए हैं, डू द रिग्रेस प्रैक्टिस. किसी भी एक दिन कोई एक चैप्टर का प्रैक्टिस नहीं करना. फॉर फिजिक्स आई विल टेल यू, पिक सम 7 or 8 चैप्टर्स. हर चैप्टर से पिक सम, लेट्स से जितना भी हो सकता है करना. मिनिमम 5 क्वेश्चन सेलेक्ट कर लो. प्रैक्टिस ऑल दोस क्वेश्चन. थ्रू दोस क्वेश्चन you will be able to practice all the formulas and things. So keep on practicing. I wish each one of you all the very best. ठीक है. So अच्छे से prepare करो. And let me know if you have any help or you want any help. You can let me know. ठीक है. Done है. चलो ठीक है. Take care everybody. Bye. And stay safe, healthy, smiling, and all the very best. Bye bye. Take care.